Hello, welcome back. The title of this lesson is called What is Radian Angle Measure? Also, if I had to subtitle it, I would say converting between degrees going to radians and also radians going to degrees. So up until this point, we have learned all about trigonometry and how to use sine and cosine and things, a unit circle in degrees, because we all know that there are 360 degrees in a circle. Now we need to switch gears and start to talk about radian angle measure. Once we now understand what to do with the trigonometry, we can then switch measurement systems into the radian system. Now the first thing you might want to say, or just ask, is why do we have two systems? Why don't we just work in degrees? Well, the truth is the radian system, as we're going to find out in just a second, is a much more natural way to talk about angle measures. So when you're generally talking about triangles and surveying and just triangle trigonometry, usually we work in degrees. But once you move past that into, I don't even want to say advanced concepts, really it's just when you move out of triangles, we generally start working in radian measure, because any kind of complex problem, anything more complex than a triangle, it actually makes a lot more sense to talk about the angles in radians. So why is that? What is the fundamental concept of a radian anyway? All right, so again, first of all, keep in the back of your mind, a circle has 360 degrees. However, we talked about why is it 360 degrees? Why isn't it 380 degrees or 400 degrees? What is special about 360 degrees? Well, the answer is you can go to the history of that degree system, and there is a history behind it, of course, but the reality of it is being divided into 360 degrees doesn't have like a fundamental, it's not a fundamental feature of our universe. It's just a human system that we made up. Radian measure, however, is much more fundamental, and that's why it's more natural to talk about radian measure. So let's talk about a circle, and let's talk about a unit circle, which we've been discussing, which has a radius of 1. That's how we're going to introduce the concept of radian. All right, so what we're going to talk about is a radius, a circle with a radius equal to 1. Now I'm going to draw a quick little circle with radius 1. It doesn't have to be exact. It doesn't have to be perfect. But we're going to try to do our best. So here is roughly y is equal to 1. Over here somewhere is x is equal to 1. Down here, y is equal to -1. And over here, right around here, is when x is equal to -1. So I'm just trying to sketch a circle with a radius of 1. I'm not going to do a very good job here. It's probably going to look more like an ellipse, but we're going to try our best to make it some kind of circle. Okay, it's not too bad. Obviously, it's not rounded perfectly, but the point is it's a circle of radius 1. All right, how many degrees are in this circle? If we start from the x-axis and we measure all the way around, we get to, of course, there's 90, 180, 270, we get to 360 degrees. All right, now let's talk about the concept of a radian, right? Let's say, since we know that this circle has a radius 1, let's calculate the circumference, the distance all the way around this circle. The circumference, you might have remembered from, 5th grade or something, is 2 times pi times r. 2 times pi times the radius. That's what the distance is. If you measure the radius in meters or centimeters, then the circumference will be measured in meters or centimeters, whatever system you're using. So, but now we have a unit circle, so that means the radius is 1. So that means that the circumference is 2 times pi times 1. That means the circumference of this circle, because the radius is 1, is equal to 2 pi, right? So let's say, for instance, that the radius of this circle was 1 centimeter, right? Let's just say. So then that would mean that the circumference all the way around was 2 pi centimeters, right? It has to be the same unit. If you measure the radius in meters, then the circumference will be 2 pi meters. So what do I mean by 2 pi centimeters? I mean pi is 3.14159 and an infinite number of non-repeating decimals, because pi is irrational, okay? So it's not a decimal that stops at 3.14, but we can approximate it as 3.14. You multiply by 2, and then that's the actual number of centimeters. If I were to measure it with a kind of a flexible tape measure and measure it all the way around, I would measure 2 times pi. Pi is about 3.14, so 2 times 3 is 6, so just a little bit more than 6 centimeters around if I measured the radius to be 1 centimeter. If I measure the radius to be 1 meter, then it's going to be just over 6 meters around. If I measure the radius to be 1 light year, then it's going to be just over 6 light years around. That's how circumference works. Now here's the thing. Since I know that this distance is just a little bit over 6, it's 2 pi centimeters all the way around, then I can use the distance around the circle to tell me basically what the angle is. Because remember, the angle is just telling me, in the previous system, we had 90 degrees up here, and then we had 180 degrees here, and then 270 here, and then we had 360 right there. But basically, since we know the circumference of a unit circle has 2 pi centimeters, then we can kind of like drop the unit measurement, we can drop the centimeters part, and we can say that every circle has 2 pi radians that go all the way around. A radian is just like pretending the circle has a radius of 1, and then you have 2 pi of those that goes all the way around. And see, that's why the concept of radian measure makes a lot more sense, because 360 degrees, it's like you pull it out of the air, and you say, oh, there's 360 of these things in a circle. That's kind of like off the wall and comes from nowhere. I mean, really, there's history there, but I mean, it isn't a fundamental thing. But this is a fundamental thing, because if I take a circle that has a radius of 1, I know because of geometry, because of the fundamental geometry, that there's going to be 2 times pi distance units around. So I just drop the distance and say, okay, there's every circle is identical, so there's 2 pi of these things called radians. So you can think of a radian as being the distance around the circle there, if the radius is 1. So what we say is we kind of drop the distances here, as we're talking about unit circles. We say that there are 2 pi radians around every circle. All right? Around every circle. So because it involves the number pi, the radian measures that you see for the angles that we're going to be using, they're always going to have pi in there. So that's why they have pi in there, because the definition of going all the way around the circle is 2 pi radians. The reason it's 2 pi radians is because if you look at a unit circle, the distance around is 2 times pi in whatever units you're talking about. All right. So for instance, if I wanted to draw a picture of it, right, I would say that if I say this is 0 degrees, 90 degrees, 180, 270, back to 360. But in this case, I'm going to say, I'm going to go all the way around and measure back to where I started from. Now, in the old system, that would be 360 degrees. So I could say theta is 360 degrees. But I can also then say that theta is 2 times pi radians. So you don't put a degree symbol. When you put a degree symbol, that means degrees. But when you have some number of pi and you put RAD, that's what you put. It tells people that you're talking about radian measure. This 360 degrees is the same thing as 2 pi radians. Now, just like you can take 360 degrees and start chopping it up, like if you chop it into 4 pieces, you're going to get 90-degree chunks, the quadrants of the unit circle. You can take the 2 pi radians and you can chop it up into pieces too. So going all the way around the unit circle, you're going to have fractions of pi, right? And we're going to learn and we're going to calculate those fractions of pi in just a second. But what you need to realize is that basically these two things are the same thing. So probably the most important thing I can write in this lesson is an important conversion factor. 360, I can put the degree symbol, but I'm going to put DEG to make sure it's all clear. 360 degrees is equal by definition to be 2 times pi of this new unit called a radian. And you can think about it as being the distance. If this is a unit circle here, every bit that I go 2 times pi distance units around, that's 1 full revolution, right? So if I go half the distance over here, then I go 2 pi divided by 2 radians, because if I only go halfway, and we're going to get to that in just a second. So you might say, well, doesn't this just work for like circles of distance of radius 1? I mean, what if I have circles bigger? What if I'm trying to measure the angle of of some large part of a circle that's not a unit circle? I mean, the same thing works for degrees. I mean, you know that. Let me draw an interior circle right here. So let's say the radius of this circle right here is 1. Okay, but you know from the previous definitions that if I draw a circle outside of that that's larger than 1, I can certainly measure degree measurements around this larger circle. If I draw an even larger circle around this guy, something really, really, really big like this, even though this is like a radius of 2, maybe this thing's a radius of 3 or 4, I can still say this is 0 and I can still say this is 90 degrees. It doesn't matter how big the circle is, in other words. There's always 360 degrees in every circle. But for radians, we say the same thing. There's always 2 pi radians, no matter how large the circle is. But the way you can think about it is, if you look inside of your circle to a circle of radius 1, you increment the number of radians as basically you walk around the circumference of the circle. So again, 2 pi is 2 times 3.1, or just a little bit over 6. So it's going to be basically 6 centimeters. If it's at 1 centimeter, it'll be 6 centimeters around by the time you get around to the other side. So when you get over about halfway, it's not going to be 6. It'll be about just a little bit over 3, right? Because 6, just a little bit over 6 radians is all the way around. So then halfway is about around 3 radians. So you're just measuring the circumference of that unit circle. That is the number of radians that you're walking around this boundary. That's why radians are more fundamental, because they actually represent geometry. You're measuring the circumference of a unit circle. That's the number of radians you have as you walk around, whereas degree measure is just some random 360 number that just comes about from history. All right, so just like we said that 360 degrees is 2 pi radians, what if I only go halfway around? In other words, every circle has 2 pi radians as you go all the way around. What if I don't go all the way around? What if I only go halfway around? What if I say, I'm not going to go all the way around, but I'm going to go all the way to here? Now we know from previous discussions that this is a 180-degree angle. We already know that, right? But we know that there is 360 degrees in every circle, and we know that 360 degrees is 2 pi radians. So what would this radian measure be? Well, if the entire way around the circle is 2 pi, then if I take that 2 pi radians of going all the way around and I just cut it in half, then this must be the measurement of half a circle, right? You can see the 2's cancel, so pi radians. Pi radians is equal to 180 degrees. And in fact, I think I'm going to write that again underneath it. It's an important note. I'm going to say conversion factors. And you can use either of these conversion factors that you want. They're both the same thing. You can say that 180 degrees is equal to pi radians, right? Or you can say that 360 degrees is equal to 2 pi radians. You see what's happened here? This is the fundamental conversion factor, but if I multiply by 2, I'll get 360 and I'll get 2 pi. Either one is the same. I honestly usually just say 2 pi radians is 360 degrees, but I know lots of people and lots of books that just say 180 degrees is pi radians. It's more fundamental for you to understand why it is the case, though. The reason that these work is because a full circle is 2 pi radians, so a half circle must be that amount of radians divided by 2. That's how you get to the pi radians. But every time you walk some degree measurement around the unit circle, it will be some fraction of some multiple of pi, some fraction of pi, because going all the way around is 2 times pi. All right, so let's take a second to do a couple of quick conversions. And let me see, how much more space do I have? Yeah, I have a lot of space. So let's go and say, for the next part here, let's do a little conversion. Let's convert 30 degrees to radians. 30 degrees to radians. So this is how you do it, and I'm going to show you how to convert units in a way that you may have seen before, but maybe you haven't seen it before. But the way I'm going to show you how to convert between units, in this case between degrees and radians, is the way that I convert units for every class, for everything I do. Chemistry, physics, engineering, electric circuits, mechanical systems, it doesn't matter. This method I'm about to show you of converting between things is way easier than just trying to wonder if I should multiply or divide. Okay, so let me show you how to do this. What you do is you start with what you know. You have 30 degrees, that's what you're trying to convert from, so you write 30 degrees. And you could put the degree symbol, but I like putting DEG just so it's easier to read. Then you draw a horizontal line under this and a vertical line next to it. And now I have to put a conversion factor in place, right? So I know that the conversion factor can be written as 180 degrees is equal to pi, or 360 is equal to 2 pi. I know that either one is going to work. So let's go ahead and use the first one. And the way you do it is you arrange the conversion factor in such a way that the units cancel. So the way you want to write it is 180 degrees equals pi radians. And I write it like this way because now I have degrees on the top and degrees on the bottom. And if you remember, things on the top cancels with things that are on the bottom. And just like any kind of division, any kind of simplification of x. When x is on the top and x is on the bottom, you cancel them. 3 is on the top and 3 is on the bottom, you cancel. 16's on the top, 16's on the bottom, you cancel. Degrees are on the top, degrees are on the bottom, they cancel. So the only unit left here is radians. So the way you do this is you grab a calculator and you take 30, which is the number you have, you multiply by pi. Anything on the top gets multiplied, and anything on the bottom gets divided. So if you take 30 and multiply by pi, and then divide by 180, the way it's going to work out is you're going to have 30 times pi divided by 180. Multiply the tops, divide the bottom. So grab a calculator, or actually don't even have to grab a calculator because we see that this is 30 and this is 180 on the top and bottom. So we can divide the top by 30 and get 1. We can divide the 180 by 30 and get a 6. So 3 times 6 is 18. So you have a 1 on the top and a 6 on the bottom. What you end up with is just a pi on the top and a 6 on the bottom. And the unit that's left is the only unit that didn't cancel. Now, you would not want to do this with the conversion factor flipped over, because if degrees were on the top and radians were on the bottom, nothing would cancel. So you always arrange the conversion factor so that the units cancel. A lot of students have problems with units because they start thinking, well, do I multiply by pi and divide by 180, or do I divide by 180 and multiply by pi? Which way makes sense? And you start trying to think about it. You don't have to think about it with unit conversions. Start with what you know, and then the conversion factor is this. That's what's given to you. You arrange it in such a way that the units cancel. The only unit left is radians. So then you multiply this, divide by 180. Of course, we don't need a calculator. We just simplify the fraction, and you get pi over 6 radians. Remember, I told you every distance around the unit circle is going to be some fraction of pi. In this case, it's pi over 6. It kind of makes sense when you think about it, because all the way around the unit circle is 2 pi radians. 30 degrees is a tiny little fraction of that, so it makes sense that it's pi over 6, a really small fraction of pi, to go only 30 degrees. Okay. Now what we're going to do is we're going to use this information. We have now figured out that 30 degrees is equal to pi over 6 radians. So what I want to do is go to our unit circle. I have left this unit circle. We have already done problems with this unit circle. Nothing has changed. All I've done is I've moved the degree markings inside to make room. What we've said is that 30 degrees is exactly the same thing as pi over 6 radians. So I'm not going to write RAD. You're going to know that when you see an angle with a pi in there, you know it's a radian measure. So pi over 6 radians is exactly the same thing as 30 degrees. So keep that in the back of your mind, and let's move on to the next topic. Now, one more thing I want to tell you before I go is that some students are like, well, what if I didn't use this conversion factor? What if I use the other one? Let's do the same thing again. 30 degrees. And let's just say for some reason you chose to use this one, that 360 degrees is equal to 2 pi radian. 2 pi radian. Again, the degrees are arranged so that they canceled. All right? So what are you going to get on the top? You're going to have 30 times 2 pi, so you have 30 times 2 pi radians on the top. And on the bottom, you'll have 360 degrees. Well, you don't have degrees. Degrees have canceled, so you just have 360. Okay? Do you see what's going on here? I can basically say I can do whatever I want. I can multiply this. 2 times 3 that's going to be 60 degrees, and I can do the exact same math there, or I can just cancel and say 2 divided by 2 is 1, 360 divided by 2 is 180. And you see what I've got is the same thing, 30 pi over 180, which is exactly what we got before. So it's going to reduce to pi over 6 radians. So no matter what conversion factor you use, 180 being pi radians or 360 degrees being 2 pi radians, it doesn't matter. Either one is going to give you the same answer because of they're the same ratio, the same conversion factor. So let's go and work through the rest of the most important angles. We already did 30 degrees. Now let's convert 45 degrees to radians, and let's see what we come up with. So we say 45 degrees. We draw a horizontal line, draw a vertical line, and we have to use the conversion factor. The conversion factor we're going to use is 180 degrees is equal to pi radians. We want to arrange it as 180 degrees on the bottom, so the degree units will cancel, and the pi radians on the top, because that's the unit we want to have in our final answer. So again, we see that the degrees cancels with the degrees. So what you're going to have is 45 times pi divided by the 180, and that unit is going to be radian measure. All right? Now, if you think about it, if you grab a calculator and just kind of verify with me, you can divide the top by 45 and get a 1, and you can take 180 and also divide by 45 and get 4. So basically I'm dividing the top and the bottom of the fraction by 45. And so what you get at the end of the day, only pi is left on the top, 4 is left on the bottom, radians. So what we have learned is that 45 degrees is pi over 4 radians. So then we can go over here to our unit circle and say, all right, now we've learned that 45 degrees is now pi over 4, so we'll write this as pi over 4 radians in this location. So essentially, the unit circle is going to stay the same. Nothing changes as far as the sines and the cosines of the angles. But we can use degree measures if we want, but soon we'll be using radian measures to do the sines and the cosines, but the exact same unit circle applies. It's not anything different. Pi over 4 is 45 degrees. All right, let's continue on. We'll continue on doing the most important ones here. What about 60 degrees? Now let me ask you just one question really quickly before we actually convert it. Okay, so this is 30 degrees. You know that double of 30 is 60. So if we want to convert 60, and we know that double of 30 is 60 degrees, what do you think the radian measure is going to be? It's going to be double of what that radian measure is. It's just an angle measure in a different unit. So if this is pi over 6 radians, this angle measure in radians should just be double of that. Let's see if it actually works out that way. All right, what we do is we start out with 60 degrees, DEG, horizontal line, vertical bar. We say that pi radians is equal to 180 degrees. 180 degrees. And actually, you know what, just for variety, let's do it a little differently. I told you that we can do pi radians is 180 degrees, but I also said that we can use the other conversion factor. So just to mix it up a little bit, let's make it 2 pi is equal to 360 degrees, because it's the same exact conversion factor. Let's just see how this works out. So what we're going to have then is we will have 60 times the 2 pi, all divided by the 360. Everything on the bottom gets divided. The degrees cancels with the degrees, so the only unit left we have is radian. So all I have to do is do this multiplication. Okay, so you can do it however you want, but if I tell you that, hey, I have a 2 on the bottom, so let me just divide 2 divided by 2, and then I'll divide this by 2, giving me 180, you can see what's going to happen. On the top, it's going to be 60 pi over 180 radians. But then I realize I can simplify this further, right? Because I can divide by 60, giving me 1, and 180 divided by 60 is going to be 3. So I'm just dividing top and bottom by 60. So what I'm going to get is pi over 3 radians. And that was equal to 60 degrees, pi over 3 radians. All right, so let's go over here and write it down. And we have pi over 3 radians. So the question was, is this pi over 3 actually double pi over 6? Well, think about it. It should be double, right? So I could say pi over 6 times 2. That would be doubling it, right? So it would be 2 pi over 6. And if I simplify this fraction, what do I get? Pi over 3. So it is double. So this is the radian measure of 30 degrees is pi over 6. If I double it to get up here, it's pi over 3. Okay, we're going to come back to that in just a second, because there's more that I want to talk about when it comes to this, when it comes to that. All right, the next, probably the most important angle measure that we're going to be using is 90 degrees. So let's turn 90 degrees into a radian measure. So let's go ahead and use that 180 degrees is equal to pi radians. Again, we arrange it like this and not upside down because the degrees have to be on the top and the bottom to cancel, so that we're left with radians. So what we'll have is 90 times pi on the top divided by 180 radians. And then we try to simplify this fraction. And of course we can do it. 90 divided by 90 is 1. 180 divided by 90 is 2. So what we actually end up with is that 90 degrees is equal to pi over 2 radians. Pi over 2 radians. So we come over here to our unit circle, and we're just going to fill it in and say this is now equal to pi over 2 radians is equal to 90 degrees. All right, now I want to stop for just a second because we are going to do more conversions in just a minute, okay? But before we go any farther, it's important to stop and look at what we've actually figured out. We've said that every circle in existence in degree measure has 360 degrees. And you've learned to chop that 360 degrees, into 90, 180, 270, and even to chop it further, 30, 45, 60, and so on. Now we're using another system of measurement based on the circumference of a unit circle. And we're saying that there's 2 pi of these radians that are in a circle because if a circle has a radius of 1, its circumference is just 2 times pi, right? So the farther around the circle you go, the more radians you kind of are crossing on your way around to 2 pi of those radians, right? Then we said, what would 30 degrees be in radian measure? We converted it, we got pi over 6. 45, we converted it to pi over 4. 60, we converted it to pi over 3. And 90, we converted it to pi over 2. So you kind of should commit these to memory. You need to commit these to memory. The other ones around the unit circle, I'm going to show you how to count in such a way that you won't have to memorize them. But the ones in quadrant 1, you should memorize. Here's an easy way to remember it. 45 degrees is the one with pi having a 4 on the bottom. That's easy to remember. 45 degrees is the only one that has a 4 on the bottom. So pi over 4, you should think, oh, that's 45 degrees because a 4 is on the bottom, okay? 30 degrees, you would think it would have a 3 on the bottom, but actually it's backwards. So the way you remember it is you say 30 degrees, it's not pi over 3, it's the other, it's pi over 6. And the same thing with this. The 60 degrees, you would think a 6 would be on the bottom, it's really a 3. So the way you remember these is the smaller number is the pi over 6, so it has to be, for 30 degrees, it's the other number, 6 over here, and for 60 degrees, it's the other number, 3 under there. So it's a little bit cumbersome to remember pi over 6 is the smaller angle and pi over 3 is the bigger angle, but after a while, you'll start to remember that. And then finally, pi over 2 is up here at 90 degrees. That's just one that you'll just have to remember, and you'll remember pretty quickly that it's pi over 2. All right, and honestly, you can remember that it's pi over 2 partly because when you look back at the one of the first conversions we did, we said that 180 degrees worked out to be pi radians because all the way around was 2 pi, so halfway around is pi, and if I cut it in half again, this has to be pi over 2. So if this is pi, it makes sense that this up here has to be half of that, which is pi over 2. So I want you to try to remember these, and at the end of the lesson, I'm going to show you how counting by radian measure, how counting works. But before I'm going to kind of count and show you how it all works like that, I want to go ahead and do a few more conversions going the other direction. So far, we have taken degrees, convert to radians, degrees to radians, degrees to radians. Now we want to go the other way, and we want to take radians and convert to degrees. So let's say we have 3 pi over 2 radians, and we want to go to degrees. How do we calculate this? So let me show you how to do it. The thing you start with is what you write down first. The way you write it is like this, 3 pi over 2, long bar, and you put the unit right on top. So 3 pi, 2 on the bottom, radian over here. You draw your vertical line, and here you don't have to worry about, oh, should I multiply, should I divide? It's just all set up for you, because the way you write it is you say that pi radians is 180 degrees. The reason you're writing it this way is because you have to make sure that the radians are the thing that's canceling. You want degrees left over. You're trying to go to degrees. So you cancel the radians and you're left with this. You wouldn't flip it over like we had done before because if degrees were on the bottom, nothing would cancel at all. All right, also notice that, well, let me go ahead and just finish the multiplication. It's going to be 3 times pi times 180. I'll write it like this, 3 pi times 180. On the bottom, you have a 2 times a pi. All right, but now we can, and then of course the unit is degrees. But notice that there's a pi on the top and a pi on the bottom, so they go away. And you have a 2 and a 180. So 2 divided by 2 is 1. 180 divided by 2 is 90. So really what you have on the top is 3 times 90. So 3 times 9 is 227. So 3 times 90 is 270. 270 degrees. So what we figured out is 3 pi over 2 is 270 degrees. So let's go over here to the unit circle. And let's mark this guy right here at 270 degrees, 3 pi over 2. Remember how I told you that every, I don't like the way this 3 is written, so let me try to clean that up a little bit. Every radian measure around this unit circle is going to be a fraction of pi, every one of them. if you don't see a fraction of pi somewhere in a radian measurement, then something's wrong. You've already done something wrong. So 3 pi over 2. And we've already figured out from before that 180 degrees was pi, so I can actually fill this one in as well. I can say that 180 degrees is pi radians. And over here at 0, we can say that there's 0 radians here, and we already know that there's 2 pi radians in a whole circle. So if, instead of going to 360, when you go all the way around, you get to 2 pi radians. So all the way around is 2 pi. You start at 0, go into pi over 6, pi over 4, pi over 3, pi over 2. We're going to fill the rest of these out in a future lesson, but you have pi over here and 3 pi over 2 over there. And I want to do one more conversion before I wrap the lesson up with showing you how to count properly in this unit system here, which is going to be really easy to understand too. What if I want 5 pi over 4 radians, and I want to go to degrees? Okay, you set it up the same way. You say 5 pi long bar over 4, the unit is radians, and now you have to arrange your conversion factor. You have to have radians on the bottom. So you say there are pi radians in 180 degrees. All right, the reason we arrange it like this is because radians is on the top, radians on the bottom, so we got the units correct. Now we multiply through. What do we have? We have 5 times pi times 180. Then we have on the bottom 4 times pi, right? And then the unit is degrees. All right, so what do we have? We have a pi on the top, cancels with a pi on the bottom. And then what we see is 4 divided by 4 is 1, 180 divided by 4 is 45. When I divide this by 4, I get 45. And then 5 times 45, if you think about it, is 225. So really, everything canceled, the pi's canceled. 5 times 45 is 225 degrees. Okay, 225 degrees. So what we figured out is 5 pi over 4 is 225 degrees. So 225 degrees is here, so it is 5 pi over 4. So by now, and we're not going to do everything in this lesson, but by now you can see that all around the unit circle is going to be these weird fractions of pi, and you might be tempted to memorize them. Like I told you at the beginning, don't memorize sine and cosine of all these angles around. You don't need to memorize things. You just need to really focus on quadrant 1. Same thing is true of here. Remember, I did a lesson in the past on how to count by chunks of degree measures all the way around. And I told you it was going to be critical that you understand that for radian measure. Let me get into it here. I'm going to do a little bit of it now, and we'll do some more of it in a later section. But it's irresistible to do it here as well. So let's start by counting by the easiest thing, pi over 2, right? So this is pi over 2 radian measures. It is a chunk of an angle measure that's pi over 2 radians. So we're going to count in units of pi over 2. So this is pi over 2. And then what would happen if we counted this? It would be 2 times that, 2 times pi over 2. What is 2 times pi over 2? Well, the 2's would cancel. It's going to give me pi radians. That's why this is pi radians. So this is pi over 2. This is 2 pi over 2's. Then this is 3 pi over 2's. Notice the angle that we actually have here is 3 pi over 2. Then we count again. So here let's go again. 1 pi over 2, 2 pi over 2's, 3 pi over 2's. This would be 4 pi over 2's. What is 4 pi over 2? You divide here, what do you get? 2 pi. So you see, these radian measurements that are around, they're the simplified fractions. You can count by radians all the way around and just simplify the fractions and get whatever is written on the unit circle. So let's say I forget this is 3 pi over 2. I don't remember, but I remember everything in quadrant 1. I know this is pi over 2. So this is 2 pi over 2. So this is 3 pi over 2. So I don't have to remember that. I just count, okay? So let's do something else. Let's count by pi over 4's. So if this is pi over 4, this angle measure, then this would be 2 pi over 4. So let's check that. 2 pi over 4. What would 2 times pi over 4 over 4 be? Simplify this fraction, I'm going to get pi over 2. So you see, I remember this, but I also can count by pi over 4. So here's pi over 4. There's 2 times pi over 4, which reduces to this. This is 3 times pi over 4, and I'm going to write this down later, but it is going to be 3 times pi over 4. This is 4 times pi over 4. What is 4 times pi over 4? Pi over 4. What do you get? Pi. So this pi Notice when we counted by pi over 2's, it reduced to pi. If we count by pi over 4's, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, it also reduced to pi. Then we continue, 5 pi over 4, that's what's written here. This will be 6 pi over 4. If you do 6 pi over 4, let's do it right here, 6 pi over 4. If you divide by 2, you'll get 3 pi over 2. That's 3 pi over 2. So this is 6 pi over 4. This will be 7 pi over 4. That's what I'll write it as in a minute, in a future lesson. This will be 8 pi over 4. What is 8 pi over 4? 8 over 4 is 2, so it's 2 pi. So really, to get to any place you want on the unit circle, just, if you're trying to count by a certain angle, just count around, and wherever you land, then you simplify the fraction. That's going to be the radian measure there. So we can continue. This is pi over 6, 2 pi over 6, that reduces to pi over 3, 3 pi over 6, that's going to reduce to pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6, 6 pi over 6 reduces to pi, 7 pi over 6, 8 pi over 6, 9 pi over 6, if you do 9 pi over 6, it's going to reduce to 3 pi over 2, 10 pi over 6, 11 pi over 6, and 12 pi over 6. 12 pi over 6, again, reduces to 2 pi. One more time, we'll do it with a different one. Let's go with increments of pi over 3. Here's pi over 3, all right, which is a 60-degree angle. Here's pi over 3. 2 pi over 3 is going to be here, right? Then 3 pi over 3 is going to be here. That reduces to pi. And then 4 pi over 3 would be here. And then 5 pi over 3 would be here. And then 6 pi over 3 would be here. What's 6 pi over 3? 6 over 3 is 2 pi. So you see, you can pick any radian measure you want in quadrant 1 and just count around the unit circle in increments of that unit measure. Wherever you land, simplify the fraction, then you're going to have the radian measure at that point. So all of these angles that I'm going to end up filling this chart in a future lesson. Right? All of those measures that I'm going to write down that you see on your unit circle, you don't memorize them. You just start counting from here and you land somewhere. That's what usually happens. If you know that this is 3 pi over 2, it's okay, pi over 2, 2 pi over 2, 3 pi over 2. This is 5 pi over 4. It's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. You don't memorize those. I haven't memorized them. You get there by counting. So make sure you can convert everything, that you know how to convert from degrees and radians to degrees. Solve these problems yourself. Make sure you kind of understand the concept here with the counting by radian increments. We'll do some more practice problems in the next lesson, and then we will finally discuss the full glory of the unit circle in radian measure.